Hi, my name is Doğukan İleri. I'm an electrical and electronics engineering student at Bilkent University. In this video, I'm going to present my Physics 102 term project. The aim of this project is to find out how the capacitance changes related to the area of the parallel plates, the distance between the plates, and the dielectric constant. The formula that will be used in order to make the calculations is going to be shown in a few seconds. Here C is the capacitance, D is the distance between the parallel plates, A is the area of the parallel plates, epsilon is the permittivity constant, and K is the dielectric constant, which is taken as 1 for air. That's the plate with an area of 100 centimeters square. That's the plate with an area of 225 centimeters square. That's the plate with an area of 400 centimeters square. That's the ruler I used to measure the distances of 5, 10, and 15 centimeters. That's the cardboard I used as the ground. That's the digital multimeter I used in order to measure the capacitance. In the first part of the experiment, the effect of the area of the parallel plates on the capacitance is observed. So the distance between the parallel plates is kept the same, while the area of the parallel plates is changing. Here you can see the value of capacitance for the parallel plates with an area of 100 cm squares and a distance of 10 cm between the plates. Here you can see the value of capacitance for parallel plates with an area of 225 cm squares and again a distance of 10 cm between the plates. Here you can see the value of capacitance for parallel plates with an area of 400 cm squares and again a distance of 10 cm between the plates. In the second part of the experiment, the effect of the distance between the plates on the capacitance is observed. So the area of the parallel plates is kept the same while the distance between the parallel plates is changing. Here you can see the value of the capacitance for parallel plates with an area of 100 cm squares and a distance of 5 cm between the plates. Here you can see the value of the capacitance for parallel plates with again an area of 100 cm squares and a distance of 10 cm between the plates. Here you can see the value of the capacitance for parallel plates with again an area of 100 cm squares and a distance of 15 cm between the plates. In the third and last part of the experiment, the effect of putting a dielectric between the parallel plates is observed. In order to do that, both the area of the plates and the distance between the parallel plates are kept the same. Then the capacitance is measured when there is air between the parallel plates, and the same procedure is repeated when there is paper between the parallel plates. Also, the dielectric constant of paper is taken as 3.5. Here you can see the value of the capacitance for parallel plates with an area of 400 cm squares and a distance of 1.5 cm between the plates. Here you can see the value of the capacitance for the same setup but when there is paper between the plates. In the first part of the experiment, the capacitance increased as the area of the plates increased. In the second part of the experiment, the capacitance decreased as the distance between the plates increased. And in the third part of the experiment, the capacitance increased when the dielectric constant was greater. So the experimental results were as expected. However, the error percentages came out to be quite high. And there are several reasons for that. First of all, the parallel plate capacitor is handmade, and that's why it's not possible for it to give exact results. Second of all, the person who is making the measurements might also be a reason for the high error percentage. Also, the environment that the measurements are made in is not perfectly stable and it might cause the error percentage to increase too. Also, specifically for the third part of the experiment, the dielectric constant of paper might be different than the value which is assumed in the calculations. That was my Physics 102 term project. Thank you for listening.